So one thing to be aware of is that the bounds of integration, those little numbers on the integral sign, can be variables as well as numbers. Typically, we use a different variable than the one in the function to avoid confusion. So it's entirely okay for us to have problems like this. Find the integral from pi over 4 to x of secant squared t dt. So what we're going to do is we're just going to do the same thing we were doing before. So the antiderivative of secant squared is tangent, and our variable this time is t. That's pretty typical when we have these problems, that this will be t and this will be x. And then our bounds are from pi over 4 to x. So what we do is the same thing we've done in the past. We just substitute the upper bound, so tangent of x minus the tangent of pi over 4. Find those numbers. Well, I guess just the one number. Pi over 4 is 1 root 2. Tangent is opposite over adjacent, so the tangent of pi over 4 is 1 over 1, or 1. And there's our answer. We'll have the x at the end. That's entirely okay. We can also see problems that ask us to have a little more creativity, such as find all values of k for which the integral from 1 to k of 2x dx equals 0. And as soon as we look at this, if we're looking for when this equals 0, for sure, when k equals 1, we're going to have the integral from 1 to 1. Doesn't matter what this is. This could be anything. The integral from a number to the same number is automatically going to be 0. So we know one of our answers is certainly k equals 1, but let's see if there are any others. So when we're doing this, the integral from 1 to k of 2x dx, we take the antiderivative, so that's x squared divided by 2 from 1 to k. So that's k squared minus 1 squared. And we're told that the integral from 1 to k of this function is 0, so we can say that 0 equals all of this. If we add 1 to both sides, k squared equals 1. And if we take the square root of 1 is plus or minus 1. So that means the integral from 1 to k of 2x dx equals 0 when k equals 1 or k equals negative 1.